All right, guys, welcome back. This is day one of the notes. We're going to do some sample problems like problems on page 383, 5, and 7. The directions. Find the position function of the particle. They'll give you the velocity machine. You have to find the position. Remember the relationship between these two. The position is one antiderivative away from the velocity. This stuff over here, this is the initial conditions. Remember when we did those initial value problems where we had to find the missing C? That's what this is right here. Another notation for this, instead of sending 0 to the S or position function, we could call it S sub 0 equals -3. And remember, there are some textbooks, including the AP book, where they call the position function x of t. So watch out for that. The initial position over here would be x sub 0 equals -3. Our book likes using s for the position, and so that's what we're going to do here. So to find the position function, it is one antiderivative away from the velocity machine. So we need to take the antiderivative of this velocity machine with respect to time. So here we go. The antiderivative of this machine is, with respect to time, raise the power, divide by the power, the antiderivative of 1, the antiderivative of the sine. Remember, you can find these things on the inside front cover of your book, or maybe you have one of the page, I think it's page 251 of your AP workbooks, okay? If anybody doesn't have the materials at home, please send me an email and we can get it for you. What's the antiderivative of the sine? Negative cosine. Plus c. That plus c value in a position function is going to be the initial position. Pretty fancy, huh? Let's find that initial position now using t equals 0 and the initial position at -3. So we have -3, shoving it in right there, equals 0 minus the cosine of 0 radians plus c. What's the cosine of 0? We erase and replace that with 1. Add 1 to both sides, and you get -2 equals the original position. I hope I've done that right. So the position function is, everything remains the same, and add your initial position plus -2. Okay, example problem number 2. Find the position function given this acceleration machine. It's the same, except for acceleration is 2 antiderivatives away from the position. So if we take, first we have to find the velocity machine by taking the antiderivative of the acceleration with respect to time. Taking the antiderivative of both sides here, again, with respect to time. We get the velocity machine, raise the power, divide by the power, raise the power, divide by the power, raise the power, divide by the power, and don't forget your constant. This time the constant, since we're dealing with the velocity machine, is the initial velocity. That's what our C value is. We need to find our C value using the initial conditions. Everywhere you see a t, replace it with a 0. And the velocity at 0 is 0. That makes it kind of nice. So we put 0 in for the velocity, and then everywhere we see a t, replace it with a 0. Well, that's going to go to 0. That's going to go to 0. That's going to go to 0, plus the initial velocity. So we know that the initial velocity is equal to 0. I probably had a good idea that that's what that was going to be, okay? So here we go. Putting a 0 in for the initial velocity, and take the antiderivative of this. Our goal is to find the position function. It's one antiderivative away from the velocity function with respect to d. Here we go. The position function with this. Raise the power, divide by the power. Add 1 to that. Divide by 4. There's already a 3 down there. Raise the power. Add 1 to that. Divide by the power. Well, there's already a 2 down there, so that turns into a 6. Raise the power. Divide by the power. And don't forget your constant. This time the constant, since we're dealing with a position function, is the initial position. This is our t value. This is the position of the particle at 0. So you shove those things in. 0, gone, 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 gone like a freight train, gone like yesterday, gone like a Civil War, something, something, bang, bang. Here we go. So the original position is 0. So plug that back in to the original, clean it up a bit, and here we go. Nothing to do to reduce that one. The 3 goes into that twice. If I ever make a mistake on these videos, shoot me an email and I'll fix it, because I certainly don't want to post anything that's incorrect. That's how you do problems 5 and 7 in your homework. Good luck and enjoy.